Okay, so as in the last video, we have discussed about the discovery of electron. In today's video, we are going to discuss about the properties or the characteristics of cathode rays. Like, for example, we are going to identify the mass, the charge of electron, the penetration power, the heating properties, or what, the chemical reactions, how does it move in the discharge tube. We are going to discuss everything, right? The first thing, they move in straight line. Alright, these rays travel in straight lines and perpendicular to the cathode surface, right? So, for example, these are, we have cathode particles, electron, negatively charged. We are going to identify the charge of it as well. We don't know, is it negatively charged or positively charged, but we are going to identify, right? So, here we have electrons. They will move in the straight line perpendicular to the direction of the cathode surface, right? They travel in straight line. These rays travel in straight line, right? So this was the first property or the characteristic of cathode ray. These rays travels in straight line, right? The second property, which is about the charge, right? How we are going to identify the charge of this particle. For example, I have this particle, which is cathode particle. Now I'll make it pass through the electric field, since I need to identify the charge of the electron, right? The charge of this particle. So here we have positive and here we have negative, and this is basically the electric field. This is the electric field. Now where will it move? Where electron will move? Since it has a negative charge or it has no any charge, right? We are just going to identify the charge of it right now. So it will gonna move, or it will gonna attract towards the positive charge, and when it will gonna attract towards the positive charge, we are gonna know that this this particle or this cathode particle has a negative charge, right? So we are just going to write here down. Wait, let me give the space so that I can write it down. I'm just going to write, when we passed this particle, when we pass through this particle, wait, let me give an through electric field, it deflect, remember this thing, it deflect towards positive charge. And here we got to know that this particle has negative charge, since it deflect towards the positive charge, and then we got to know that it has a negative charge, right? So now we have identified that how they do travel. They travel in a straight line. Second property, wait, let me give the numbers too. This was our first property. This was our second property. When we pass this particle through the electric field, they deflect towards the positive charge, which means they have negative charge and they are attracted towards the positive charge. Now we are gonna identify the mass of this particle, right? Does this particle has mass or not? For example, for identifying the mass of this charged particle, we need to make it pass through the magnetic field, right? Now we know that north is on the up and south is on the down, but it is okay if I'm making north in the downside and south in the upside, right? And this is what? This is whole magnetic field. Magnetic field. When we pass this electron through this magnetic field, it basically deflect towards the north. And we know that when the particles or when something deflect towards north, means they have mass, right? So I'm going to write here, means they deflect towards north, means they have mass 2, right? When we pass this electron through the magnetic field, they deflect towards the north side, and here we gotta know that this particle has the mass 2, right? So this was our third property, which means they have mass 2. Now the ratio of charge and mass, we call it as EM, charge to mass ratio. This is basically charge to mass ratio. This is charge to mass ratio, or you can write EM, which means E is the electron, which means charge on it, and M represent the mass, which means it is the charge to mass ratio. Now let's identify the charge to mass ratio of hydrogen, right? So let me write this here. Hydrogen has a charge, we know that is 1, right? It has 1, and mass of hydrogen is also 1, so it has 1 EM, right? 1 EM. So hydrogen has the greatest EM of all the atoms, right? For example, if I'm taking the EM of oxygen, oxygen has charge, that is 1, we know that, right? And it has mass, which is 16. When we'll divide this, we'll get something, right? So there it will be the light, right? Lightest, not lightest, however lighter than the hydrogen EM, right? Whenever the atomic number or the atomic mass will be increasing of the atoms, their EM will be lighter, right? So this is basically charge to mass ratio. Now we are going to discuss about the penetration power, the fourth property, which is penetration power. Let me write this here. I'm going to write this here. Penetration. This penetration, which is basically injection in solid body, right? In solid body. Now let's see how much does this electron or this cathode particle penetrate, right? Basically this is, we have Cr, or I can make this Cr with red color. This is, we have Cr. Cr means cathode ray, right? And this we have a wall. This is the first wall I have, right? This is the first wall. Here I got to know the second wall, and here I have the third wall, right? Third wall. It will gonna pass through by the first wall, but it will not pass or penetrate the second wall, since it has not that much penetration power as we have in the neutron, right? So by hitting this second wall, it will gonna reflect back, right? So it has not that much penetration power as we have in the gamma rays. For example, I'm making the gamma ray now, right? So gamma rays has no charge plus no mass. This is massless plus chargeless gamma rays. So it will gonna penetrate a lot, right? It will gonna penetrate a lot. So this is basically, we have gamma rays. Why does this gamma ray penetrate a lot? Wait, gamma ray. Because this is chargeless plus massless. Chargeless and it is massless. This is chargeless and massless. That's why it does penetrate a lot, right? Now we are going to discuss about the ionization part, right? Let's discuss about the ionization part. This was the third property. Let me write here down the penetration part. Now let's go and discuss about the fourth property, which is about the ionization, right? So let me write here ionization. Ionization is what? It basically is you know what, it always happens in the neutral body. Wait, let me write this first. It always happens in neutral body. For example, if it's going to happen in the atom, it will happen in atom, because we know that atom is neutral, right? It will going to happen in molecule, since molecule is neutral as well. It will going to happen in compound, since compound is the neutral as well. So it will going to happen in every neutral body. And cathode ray has a property of ionization, which will it will gonna ionize, right? For example, I have Cr here. I have Cr here, which is cathode ray, right? When it will gonna, for example, I'm making an atom here. So I have an atom here, which is basically an helium atom, 2 proton, 2 neutron, right? And it has 2 electrons as well. 2 electron, 1 electron. Wait, let me make this with or with white, so that it can be more easy to understand, right? Initially, let me make the orbit. Okay, then we have electron here and here. When we're gonna the Cr will gonna hit this electron, it will gonna repulse, right? Here what will gonna happen? Repulsion. Let me write this here. Repulsion will gonna happen here, and because of this repulsion, this electron will gonna be separate, right? So now here we have an atom, here we have 1 electron. Since 1 electron is repulsed, right, 1 electron is knocked out, and here we have positive charge now. So this Cr has a power to ionize the neutral bodies as well, right? So this cathode ray is used for ionization. Used for ionization. This cathode ray is used for ionization. Now we are going to discuss about the fifth property, which is about the heating, right? Here I'm going to write the property of heating, which is the fifth property. Wait. This is the fifth property we have. Wait, let me make this diagram here so that I can be able to write too. For example, I have this Cr, which is, we know that this is cathode ray, right? This is going, and here we have a thin foil, right? Here we have thin foil. Thin foil. Now here the particles inside, when this cathode ray will gonna hit this particle, they are gonna transfer the momentum, plus they're gonna transfer the kinetic energy too, right? Transfer, wait, let me write this with white color. They're gonna transfer the kinetic energy, plus they're going to transfer the momentum too. And when this kinetic energy will going to transfer, means the particle's temperature will be greater, right? Get higher. Temperature will get higher. Means this Cr as heating properties as well. For example, this is particle. This is particle. It will gonna transfer its momentum plus kinetic energy, right? This transferring, right? This is transferring its kinetic energy and momentum in an other particle, right? I'm not writing momentum, however, just mentioning P, because we know that P represents the momentum, right? So this is basically the heating property, which is the property number 4. Not property number 4, however, this would be the property number of 5th, right? Because ionization was the 4th one, and now we have moved towards the 5th property. And this is about the heating properties or characteristics. Heating properties. Now we are going with our last property, which is about the chemical reaction, right? So chemical reaction, how will it gonna take place in the chemical reaction? Because we know that electron, whenever electron will be there would be chemical change, and whenever there would be neutron, there would be nuclear change. So chemical change will always be occurred by the electron, right? So this is the 7th property. Chemical change will always be occurred by Cr, which is known as electron, right? So this was the 7th property. In the next video, we're going to discuss about the discovery of proton, which was done by Goldstein.